Now come to the fourth topic in Coordinate Geometry Basics, and this is to find the angle between two lines. So you get the equations of these two lines, y equals mx plus c and y equals nx plus d. Now the angle between these two lines will be the same as between the lines y equals mx and y equals nx. It shouldn't be too difficult to understand that. Okay, and of course this will be the easier way in which to deal with it. So let's draw a diagram. Before I proceed with that, you might say that you could quite easily now get the result by appealing to the compound angle formula involving tan of theta, but that is highly dubious logically because of the fact that the way that particular formula was relied heavily on geometric methods. So it would be very questionable to use that straight away. So what I'll do is try and prove this entirely by geometry methods, almost. So let's say that these are our two lines. That's P, OP and OQ. Now there's no loss of generality in taking that the coordinate of that point is 1 because it doesn't affect the size of the angles at all. I call the other line OQ. Okay, so OP we'll say is y equals mx, so the coordinates here are 1 and m, and Q is the line y equals nx, so the coordinates here are 1 and n. So this length here is equal to m minus n. Let that be the angle in question. All right. Now the length of OP by Pythagoras' theorem will be square root of 1 plus m squared. All right. And the length of OQ will be square root of 1 plus n squared. Right, and now use triangle areas. Using triangle areas. Okay, so the area, twice the area of triangle OPQ will be simply m minus n, that's the length PQ, multiplied by the height from that base, which is 1, so that is simply m minus n. But also twice the area of the triangle will be square root of 1 plus m squared times square root 1 plus n squared sine theta. All right, so sine theta equals m minus n over the square root of 1 plus m squared times 1 plus n squared. That would suffice. That's a square root sign there. Okay, that would suffice for our purposes. However, it is more usual to express it in terms of tan theta for the simple reason that it is easier to remember. So let's see how we can get that done. By drawing a little triangle here. That's theta. That's m minus n, and this side is the square root of 1 plus m squared times 1 plus n squared. That's by the definition of sine theta. So we need to work out this side here. Again, just using Pythagoras' theorem, that would be the square root of 1 plus m squared times 1 plus n squared minus m minus n all squared. That actually quite easily works out to 1 plus mn. So from that, we can see that tan theta, moving upwards, tan theta will equal m minus n over 1 plus m times n. And that is the more usual form in which the angle between two straight lines can be found. I don't quite finish there. We do a special case. And in this special case, suppose theta happens to be 90 degrees. Okay? In which case, tan theta, tan of theta will tend to infinity. Okay? Now will tend to infinity if the denominator of the formula is equal to 0. Okay? So this will be if and if only if 1 plus mn equals 0. Okay? So that the product of the gradients mn is equal to minus 1. That is a fairly commonly used result. And I'll end on that note.